Başlayalım isterseniz. Verinin gücünü kullanarak varlık optimizasyonu oturumuna hoş geldiniz.
Well, welcome to our session. I'm the moderator, Ufuk Yaman.
Aynı zamanda Yunus Enerji Çözümleri Genel Müdürüyüm. Kısa bir giriş yapmak istiyorum konuya. Gelişen teknolojileriyle yaygınlaşan enerji dijitalleşme
Well,
uygulamalar arasında
with respect to digitalization applications,
yapay zeka
big data and AI have become really prominent, and in the recent years, data collection and data processing technologies have increased our access to data, and it made possible to turn data into action. So thanks to this, we can increase the productivity and we can optimize the cost and maintenance requirements. But the most of all, we could minimize the failures in the critical components. In the renewable power plants, predictive maintenance and assets management will be the topics of the session, and we're going to be talking about optimization of the costs and asset optimization by using the power of data. First and foremost, I'll start with Murat Yilmaz. We know him in the sector. In the past, he used to be in Aksa Energy, in Energy Investment, and in the turbine manufacturing. He worked in Vestas, and right now he is the co-founder and CEO of Kavaken. Well, Murat Bey, what would you like to say about the asset optimization by using the power of data? We know data is very important, and reaching the critical data and qualified data is of great importance, and it is a bit problematic. So how do you receive data that are inputs of your studies? Well, thank you so much for your introduction. In the data area, over 15 years, I've been working in the wind sector, and in the wind sector, we are gathered together in Turek, and there is this great panel allocated to data, and it shows how important data for our sector. So first and foremost, we have to start with the presence, availability of the data. As wind energy, we are a little bit lucky since due to the principles of the functioning, wind turbines need data. During operation, they need to know the direction of the wind, the pace of the wind, and also they need electrical data, and they also need their own components data. They have to take everything on real-time basis, and they should be processed. They are received, processed, and they are recorded in their SCADA systems in once in 10 minutes. Up until this time, this data hasn't been used. They have been idle up until this time. Receiving and processing the data have been a big problem so far. Turbine companies, OEM, have their own SCADA systems. They have their own softwares. And these SCADA systems don't have standard to keep the data. So they have their own data system, data set, and in the format that they have described, this data is kept according to these procedures. And receiving the data from the system, normalization of the data. So what do I mean by normalization? Well, I've mentioned the wind direction that the turbine has to utilize. Some turbines use absolute data based on the north. Some turbines can take the data and keep the data on a relatively different directions. So you have to normalize and bring all the directions to a common point. And this is a really big job. And we thought that it was much more challenging than we thought. For 3 years, we've been working on the sector, and still we are working on this. As Kavaken, as of this moment, we work with 5 different turbine OEM companies. We can receive 5 different OEM data, and among the models of each and every brand, SCADA system, data utilization could be various. For that reason, this is also another problem. I've told you that there's data and there's also the receiving side of the data, so receiving data from the turbines. And I'd like to also make a self criticism because for 8 years I worked in Vestas in the sales part. I was working on the sales contracts of the turbines, and back then, with the standard contracts of sales, we were not attaching importance to data. It was from other countries, it was standard, all the contracts were adapted according to this, were harmonized according to this. And when some of our customers asked some special data, we didn't understand why they asked for this kind of conditions. Well, actually, I could learn some lessons, and I am actually trying to get the data right now for the contracts. But sector is getting into a good direction, I believe, because there are some power plant owners that are aware of the necessity of the data. On the technical side, yes, it is a bit problematic, but turbine companies can be also very supportive. So after you receive data, by the way, the things that I have mentioned so far has been related to the data receiving. So what do we do after we receive data? Well, the first step is to visualize the data. This is the first step, but visualization is not sufficient just by itself. It's a nice step, but this is not sufficient. Well, we have to make an analysis here. This is important. We have to get some meaning out of this data. And how can we do this? Well, turbines, whether they do function productively or not, they perform well or not, this is important. And components of the turbines are subjected to any failures or not. Well, sometimes things can go normal, but there could be some indicators pointing out some future failures. We try to analyze it based on the data. Let me give you an example. Well, these things could be understood better with the examples. Well, power curve. This shows this power curve is the best indicator for the performance. When you visualize power curve, there is a theoretic power curve. You can make a comparison. However, it might not give you proper information. Well, turbine theoretical and real-time power curve could have some differences. It depends on the conditions, like the angle of the wind and also the direction of the wind and the weather conditions and also the turbine's own sensors on certain places. There is nasal transfer function component behind the blade. There is this ratio used, and there are a lot of variations, and they are not matching up to 100%. These components are not matching, they are various. Well, IEC 61400 power curve verification technical specification, it is also stated that there is going to be an uncertainty. So what could we do about this? We check this, and each and every turbine is affected by these conditions, but each and every turbine has its own power curve, and this is called as baseline. This is like an ID for a turbine. So how these turbines function based on these special conditions. So our algorithms can compare the power curves. And when there comes a loss of productivity or decrease, our algorithms can send us some signals. Very recently, we've had a case with one of our customers. Well, our models gave warning. They said that there was 5% reduction on the generation, and then we made root cause analysis, and on those analysis we saw that two sensors were measuring the wind direction, and when there comes a problem on one of these sensors, it switched from primary to backup, and the alignment was not the same. There was a 5 degrees of discrepancy. So, unless you make data analysis, yeah, it might seem that everything is functioning, everything is very good in terms of production, but it is very difficult to understand that 5% discrepancy unless you have data analysis. So, till the end of the turbine's lifetime, you could have this risk unless you make data analysis. And some abnormalities might happen on the turbines. CMS systems and the main components, they used to be available, but CMS systems could be done with the analysis of the high value data. Yes, we make vibration analysis as well, but it requires a different kind of analysis. We have to interpret this. Even the turbine companies don't have this expertise. They work with external CMS companies. And other than this, there is the heat, pressure, hydraulic systems, electrical main component information and side component data. We receive each and every information like this and we make modeling. And based on the abnormalities that we detect, we try to understand whether we could predict some problems in the turbine. And by analyzing this data, turbine companies can also interpret the data. So transparency of the data is very crucial. Turbine owners and technicians might interpret the data. Well, of course, interpreting data out of this scheme gives the turbine owners really big strength. Wind Europe has carried out a study very recently. By 2030, workers, employees in wind area will hit up to 145,000 people. 35% of this comes from the maintenance side, so we will need huge labor here. Data transparency, data analysis, as they are also owned by the power plant owners, we believe that it's going to make the facilitation easier, operation of the power plants easier. Like I mentioned in the first round, I don't want to um, take much of your time as well. I don't want to just go beyond my time limitations. So actually, we are going towards a good direction, and it is not idle anymore. We try to get use of data, and the power plant owners understand the importance of data. They try to do something with data. Turbine companies are supportive. So at the very point of the sector, we've come a long way. 10 years ago, it was not possible to talk about the data, but right now we can share the data with the power plant owners and we could carry out a good work with respect to data analysis.
Teşekkür ederim Murat Bey.
Well, thank you very much, Murat Bey.
Sıradaki sorum
And my next
uzakta
question is for
uzakta
Mr.
çok iyi
Güven. Güven Bölükbaşı.
komutan hava tahminleri veya intelligence'ı nasıl çevirelim? Hava istihbaratı zekası, bakın. Hava zekası firmasının kurucu ortağı ve
Is the
CEO'su.
CTO of the
Yaklaşık 40 yıl
cloud
verdi. Veri bilimi ve mobil programlama konularında uzman.
co-founder of meteorology from cloud and technology. Well, Güven Bey, like in every area, in the renewable energy area, data amount increases day by day. This big data amount increases exponentially, and at the same time, data storage and analysis costs have dropped. So when we look at the development on AI and big data, what can you say about opportunities to be received from this development? Well, thank you very much for your invitation. Well, I work on the data analysis, and data strength is one of my actually ambitions. Like you have mentioned, each and every second data increases here. At this very room, there is too much data transfer. And if I'm to give you small statistics in 2021, I guess the data amount in the world was like 79 zettabytes. Zettabyte is not something that we could calculate on our mind, but it's too much. Well, this is the case in the world and as a research world, we take more importance, attach more importance to data, we collect more data. So the operation processing material costs do decrease. And so processing data has become easier and less costly. And I think you could remember this, like in my college years, for instance. So sending an email was like 5 megabytes, 3 megabytes, but right now, gigabytes of data could be consumed, processed very easily. And 70 terabyte data per turbine is the case for our sector, and it equals to 300 gigabytes of data on a daily basis. So there is huge data, as you see, and data processing follows it very well. Well, I'd like to take a back step from the renewable energy sector. So what can we do with usage of the AI or big data? Let's go out of the renewable energy sector. So by utilizing big data, what kind of problems could be solved? Well, atmosphere and the weather conditions are very crucial for us because weather conditions are equipped with too many components for analysis. Well, when you try to get data from each and every square meter in the world, and when you think of different atmospheric conditions, uh, you have to make instant changes on terabytes of data, but data has become less costly. There is also weather condition domain, and I'm sure that you have also felt this. Well, a lot of people, I'm sure, wanted to come here by wearing T-shirt, but when I check the date, it's November, right? So there is a change. There is a shift in the world. This is obvious. There is a shift with respect to climate, and we are at the very middle of this shift, and we feel this shift, and the world also feels the shift, and we have to have a stance against climate change, and we need to have some actions like renewable energy for climate change. And big data should be understood more easily, and we've also seen that this is easier to understand, this is easier to data process. So weather conditions and big data could go hand in hand. When they are merged, a really rich land occurs to be explored. We could produce weather intelligence solutions by using big data, and we wanted to step in renewable energy. Well, I have taken down some notes, by the way. November 4th, in Bakırköy station, weather was 27 Celsius degrees. Yeah, 27, 28 Celsius degrees, and it was a big record. Well, as you see, there is a changing weather pattern, there's a changing climate. Well, this is a problem, and we should approach this problem with big data, and we could get really big successful results. And we could interpret this for renewable energy and wind turbines. Where are wind turbines located in the world? Well, actually, we could collect the highest amount of data, which is also related to weather conditions. For renewable energy domain, I believe wind seems to be the most appropriate place to start. And with respect to intelligence and weather conditions in the world, as of this moment, World Economic Forum has made a statement. According to their statement, on a daily basis, $1 billion of loss occurs due to weather conditions changes. And this is a huge number again. This is not something that we could compensate easily. And in MEA region in Turkey, in the last 5 years, there are increases on occurrences of thunderstorms and big storms by 50%. In EMEA region, this has increased very much. So as you see, there is also an opportunity. In an answer to Ufuk Bey's question, I could say this. Specific to wind turbines, I could say that lightnings and thunders and heavy rains, in order to protect the wind turbines, in a lot of places, wind sector could be nourished with weather condition intelligence. We have an algorithm of thunderstorm. We're going to say that do not send anybody to the field because otherwise there could be lightning problem and it could be related to safety issues. So, thanks to this small weather prediction intelligence, wind turbines could be kept in a safer position. They could be operated much more safely. So, weather prediction intelligence could also be integrated to safety and security. And other areas are related to optimization, as Murat Bey has also mentioned, since big data is very plenty of other components, but we could integrate weather conditions as well, and we could make optimizations. Okay, and let me wrap it up. What kind of inputs do we have? Now it is getting less expensive to reach and collect and process big data. Thanks to the SCADA system's maturation, big data communication has become easier. Well, it gets less expensive, it gets cheaper to reach and process data. And second thing is related to the weather conditions. As you all know, weather affects our lives very much on a daily basis, and as there is too much data attribution on the weather, it could be interpreted more easily. Weather predictions and renewable energy, how are they related? Well, in wind power plants, Pearson correlation was found to be 87.6%. This is related to the effect of the weather on productivity and electrification. When we have a look at the correlation in between them, most important factor has been found to be wind direction and wind heaviness, wind pace. So, in a nutshell, weather conditions. Well, they are very much integrated in this respect. And from the weather intelligence, we try to produce solutions for wind sector, and we try to merge these domains. This is a really exciting process because we also feel the climate change on a daily basis, and a weather intelligence that could be utilized for the wind sector has made us also very enthusiastic. Thank you so much.
Sıradaki sorum Cem
Next
Akkuş. Kendisi Huawei Türkiye'de ürün
speaker is
geliştirme
from
müdürü.
Huawei,
Cem
Cem
Bey
Akkuş.
yıllarca Gülüş Holding
He is
bünyesinde
the product
işletme
solutions
ve
manager,
operasyon
and
yöneticisi
he
olarak
worked in Güneş Holding
dolayısıyla 12
for
yıldan aşkın bir genel
management,
müdürlük personelinde tecrübesi var.
and he has experience in this sector for
Cem Bey
12,
birinci
13
olarak
years. Cembei, by using
işletmelerde
data,
bakım maliyetlerini düşürmek
is it possible to
mümkün mü?
decrease
İlk konuşmacımız da
maintenance
söyledi.
costs, operation
Siz bu
costs?
konuyla
Yes,
ilgili
it is possible
yorumlarınızı
actually, because the
neler
first speaker has
olur?
also mentioned this. As Huawei, what do you have as solutions for this problem? Well, thank you so much. Thank you very much for this great event, and thank you so much for coming here and sparing time for us. Well, actually, we are in the correct place to talk about these issues. Murat and Güven have mentioned these issues. It is to reach the data and to carry out proper analysis, and our renewable energy power plants, interrupted production should be prevented, because we try to increase renewable energy power plants, and we try to increase their grid to the penetration to the grid. We support this, that is correct. And as they have more investments, imbalance on the grid increases as well. This is obvious. So it is possible for us to eliminate this with different components, but we have to decrease this interruption on the generation by getting use of the data. Well, actually here, first and foremost, as Güven and Murat have mentioned, we have to reach data, and we have to analyze the data very well, and we have to be tracking the data. This is the Fusion Solar of Huawei. We have a management platform of Huawei and other inverter producers in the solar area. They have similar softwares, but the important thing is to be able to reach the data and track the data. With different platforms, screens, visuals, you have to be following it very well. Well, one of the most important things here is that this analysis, like Murat has mentioned, in a wind turbine there is power curve. Yes, that is correct. You have to see power curve. This is really important. You have to analyze this. But there are some results, consequences as a result of this analysis, and based on this, you can take some actions. Sorry, and there is this asset optimization, and maybe by analyzing these assets data, you could make some predictive analysis, right? This is valid for wind power plants and solar power plants. So maybe we could forecast the potential failures, and we could make the predictive maintenance before the failures take place. Well, I'm talking about reaching the data, following the data, tracking the data. As you see on our visuals, it is not only related to renewable energy. As a regulation has changed, energy storage systems are going to be integrated to our power plants and systems. So for that reason, they should be also tracked, they should be traced back. All the data should be processed, and relevant precautions should be taken. For example, in this picture, you see an energy storage container system, and batteries, state of charges, or state of health, it doesn't matter actually. Their status could be tracked very well, and we could visualize a failure, and we could actually trace it in a 3D manner. And management systems can help us for the analysis of the facility in a comprehensive manner. But as it has been mentioned, we carry out this analysis for some purposes. We need to have an enhanced, optimized management. Thanks to this, we should be able to decrease maintenance and failure durations by 50%. So, what do we mean by this? Rather than making an inspection on the field, we should be able to analyze the data very well, and we should determine the very specific points on the field before we go to the field. Well, capacity factor of the system and availability of the factor should be kept in the desired level if we make the proper analysis. Well, here I'm on the investment side as well. I used to be on the investment side, so this is also possible to carry out daily, monthly, weekly analysis, and KPI charts could also be created, but with the visuals as well, you could have correct failure determination and availability and capacity factors could be analyzed. Well, in the renewable energy power plants and on the ESS side, the strength, the power of the data, being able to analyze the data and also carrying out predictive analysis on the field and accelerating them are very crucial. So for the first part, I could state this. Thank you so much. Well, thank you.
Son konuşmacımız
Thank you very much. Our last speaker in the first round is Cem Yumruktepe, RES Anatolia. He is the Asset Management Director. Well, we've known him for a long time in the sector. He has worked in the wind sector for a long time for different investors, and in the last 4 years, he's been working in RES Anatolia.
Res Anatolia'nın da aslında bu belki son dönemde bizim dikkatimizi çekti. Bu yıllarda
Well, it has taken our attention very recently. In Turkey, we have seen this.
performansının optimize edilmesi,
They work on the optimization of the turbines on the wind power plants.
değerlendirilmesi konularında nasıl bir çalışma yürütüyorsunuz?
What do you do for the analysis and inputs of the outputs of this analysis? Well, thank you so much, Ufuk. With the data analysis method, we could track and optimize the turbine performance. Yes, we do have solutions for this. Maybe I should be summarizing these solutions and services. Let me summarize it. As Murat has mentioned, as other speakers have also stated, accessibility and being able to receive data are very crucial. Then there comes customized softwares, and our analysis team can analyze and process the data. So as a result of this analysis, we receive some outputs. Those outputs are turned into deliverables and they are reported. So this is how we function. We do have these 3 pillars. Well, here the source of the data is the turbines itself. Turbines on SCADA and CMS system, turbine servers. Yeah, everything is about the turbine here. And in Turkey, when you think of the investors, wind power plant operators, almost all the investors have made long-term contracts for maintenance. Maybe I could rephrase your question, because this is also asked by the investors. Yeah, you're going to get the data, you're going to analyze the data, and you will take some actions for increasing the performance. You will make recommendations, but the data is going to be provided by the turbine supplier, and the product of the turbine supplier, the performance and the maintenance and the quality is also checked, controlled. Isn't it a conflict of interest? This is the question that they're asking. So in the access to data and with respect to sustainability of the service, can there be a problem? This is the question they ask. Maybe I could talk about RES Anatolia a little bit. RES Anatolia is active in 13 countries. In 13 countries that we are active, we have 14 gigawatts of power plants currently. We operate 14 gigawatts of assets, and 11 gigawatts of these assets is wind. And in wind power plants, as project developer, we make the construction and the commissioning, and we also make turbine supply contracts. So 11 gigabytes of portfolio, majority of it is supported with maintenance and repair services. We give the services to our contracted parties. Yes, as I've stated, we've had commercial and technical cooperations because we speak the same language and we trust one another. Well, first and foremost, I wanted to mention this. And also, maybe I could also mention something else. Well, let me check my notes because I don't want to skip anything.
Burada şimdi burada tabii
Well,
dolayısıyla
now
burada
here
çıkar çatışması söz konusu değil.
there is no
Aslında burada
conflict of interest.
hem türbinin performansını arttırma yönünde hem de
For the
türbinin
increase of the
güvenlisinin
performance of the turbine
türbinin
and
kalitesini arttırma yönünde
for
bir
the
çalışma
increasing of the quality of the turbines,
hem yapımcı yönünde
there
hem
seems to be an
ister hizmet
opportunity
sağlayıcılar yönünde hem de
for the investors, for the service providers,
türbin
for the
tedarik
OEMs.
bu üç sacelanın da ortak bir
These
türbinin
three
uzun
pillars have one common target, right? They all want these turbines to function in the long run with more success. So up until this time, yes, access to data is very crucial, and providing sustainability and continuity of the data is very difficult. But we cooperate with turbine suppliers, even though there are some technical problems from time to time, but thanks to this cooperation and collaboration, we could solve these problems. That's all I'd like to say. Thank you very much, Cem Bey. Then let me just mix the turn a little bit. Güven Bey, you make weather predictions.
topladığınız rüzgar santrallerinden topladığınız büyük veri
Big data collected from wind turbines. Are they facilitating your data collection? Are they decreasing the uncertainties? And for how long you could make predictions, like, I mean, for 1 week, for 1 year? Well, first and foremost, let's say tomorrow at 1 p.m., how much energy is going to be generated by wind turbine? 3 days later, 5 days later, at 1 p.m., how much energy is going to be generated? We are trying to learn this. This is like a data science project. What do we have? Well, we have big data, that is correct. Let's say in the last decade, the wind turbines data has been collected for 10 years, once in 10 minutes, from SCADA data or else from different systems. Certain input has been entered to the system and we have collected this data. And how can we make the best prediction out of this data? Well, in the data science, the first question that we need to ask is that this generated energy, this realized energy, is affected by what in the most influential way? Wind direction, wind pace, weather conditions. Well, these are the most effective things, right? First and foremost, we have to find the most important, best weather prediction. Yeah, best weather prediction. Then we could merge it with the data that we collect. At the end, it's like a machine learning or else deep learning or else AI. We could create a machine learning component. Well, some power plants can only ask this for the upcoming 24 hours. Some power plants ask it for the upcoming 5 days, etc. Because everybody has a different style to make predictions for the potential energy generation. Per-day or intraday market models are created, and the wind power plants, best plants are tried to be entered. People try to avoid having penalties and they try to decrease the cost of the operations. For that reason, data is very crucial for wind power plants. This is our perception. Well, like I mentioned, weather predictions are very crucial. Pearson correlation is, I've mentioned, 85 to 87%. If you know the weather prediction very well, and you could predict the predict. You could predict the generation of the tomorrow, actually. Well, okay, how we can make the prediction better? This is the question as well. They say that I get it AccuWeather, I get it Google, and on my phone there is also weather prediction. There is also wind estimations. Why don't we use them? Yes, of course you could utilize them, but wind power plants are placed on a unique place, right? Based on a long time of feasibility studies, it is exposed to high level of winds. But if you utilize a random weather prediction, there could be mismatches, right? So what do I need here? You need to say that I need special, specific, customized weather prediction to my wind power plant. Per turbine, let's say there are 19 turbines, we could make 19 different weather predictions. So let's say one turbine is tilted towards northwest, the other side could be a little bit higher, it could be in a slopey place. So when this happens, we could get weather prediction per turbines. Then we could have AI supported energy generation. I use the word of model because we're talking about the AI model, and also next to that there is atmospheric model. So this is like a weather prediction model. They should be brought together. So our company's name is Cloud and Meteorology. So on the meteorology, atmospheric model is created, and then we support it on the cloud, and we produce a customized solution for wind power plants. Currently, this is done under the domination of a Spanish company, as far as we see, but as a Turkish startup from this geography, we are hyper domestic, hyper local, and we make very successful weather predictions. And we have some international agreements as well, so we'd like to go on this way further. Well, it is nice to hear this. Thank you very much. So, because there are not many technological startups from Turkey, thank you. Yeah.
Ortalamayı temsil etmiyoruz. Peki o zaman
Well, let's talk about another Turkish technology startup. We will have a 5 minutes round for each panelist is speakers. Mr. Murat, we know that AI is shaping the customer and consumer habits. Yes, as you mentioned, it's impacting and it's transforming all of the industries, and it's not easy to avoid it. So we seize it as an opportunity in wind energy. What do we do, and what's our plan? What's our vision? We will talk about all these topics, but let me first start with why we are here. Wind energy dates back to 15 years ago since we established our wind farms. You purchase your turbines, and you get your grants, and you have the availability of 75%, and now continue with the production. No further questions asked. Now you see that the cost of installment is as high as the other conventional energy production. So we increase this availability up to 100%. It is available 100%, but is it efficient? As we talked in the first round, efficiency is very much related with the AI. If someone has like 1400 of turbines, it's not possible to analyze the data of these turbines. But AI can do this monitoring and analysis 24/7. And predictable maintenance is also another issue that we have to deal with. There is a scalability of the temperature of the turbines. For example, there is a limit to 80 Celsius degrees. If they have a rumen that's working up to the 80 degrees Celsius is not the same in other season, but the scale misses that. So our modeling systems our modeling systems are aiming to achieve this. They are all activating these systems, all the sensors. They're establishing a sensor system, and within the system, it's not just about the human eye. It is also questioning the deviations, it's analyzing the algorithms behind it. If there is a problem, they can detect the problem. That's the basic principle of the algorithms. The next step is not just about detecting where the error is, also it's detecting the patterns and finding the root cause of the errors and failures, whether it's cooling system or is it another thing. You can also get the answers to all these questions. This is all we are working on. So what can we do next? What's our vision? We're not talking about a far future. We are also, maybe we talk about storage systems. As Mr. Güven mentioned, there is a density of these data. Maybe in this sense we can increase our computational strengths. We are talking about these integrated systems, components, and all the modeling systems, storage, everything that's working in cohesion. This is the system that we are aiming to achieve. That's what we have to do in the electric system. You can see that if you do not achieve, other countries are doing that. We're not left behind. We are also a player in this game, like startups and other companies are working in this area. We are ready to contribute, and we are taking firm steps towards this future. Thank you so much, Mr. Murat. Mr. Cem, let's give the floor to you about the monitoring of these turbines and optimization of these wind turbines. So, what type of benefits can we get? Well, we have some report issuing periods. We also present the analysis. It's available in these reports. You can take necessary actions. You can take the necessary precautions so that the turbines can work more efficiently. But apart from that, as other panelists touched upon, another important thing is analyzing these data. It's not just about issuing a report. It's also important to establish a user-friendly platform so that they can monitor it, seeing it benchmarks according to different metrics so that it can be available to the investor and to end users. So data and data analysis and outcomes also provide this benefit to us. In the plans, you can see the investor can have this transparency. They can benefit from this transparency. That's also a valuable outcome. The momentary outcome of these turbines and performance outcomes are also important, but maybe a data you obtain from scale, it may show an anomaly, but maybe it's not impacting the performance at all. What do I mean? Maybe there is a small harm in a main component in the SMA system. You can see this. Maybe you see the temperature, maybe you can see a failure. It gives an alarm in the turbines. In a short period of time, it doesn't impact a lot. It doesn't have a negative effect. But these anomalies, these problems may lead to main component loss and other type of harms, and maybe energy loss and other type of damages. So it's really important to detect these anomalies because they may cause a huge loss or damage. So it is really possible to detect these thanks to data analysis. I'm so sorry, I'm really excited. I'm sorry, my apologies. So, turbines are installed in an open air operating 24/7. That's the aim and wish of the investor. It has to be used in a high performance level for 3 decades at least. So we have to take the necessary precautions and detect the problems and do the necessary data analysis. So I believe it's really important as well as increasing the momentary performance. Thank you so much, Mr. Jam.
Peki o zaman bir yapay zeka
Well,
konusunda
let's talk about
istiyoruz.
AI. Huawei is really experienced about this. Huawei has an experience about the control of this AI. What's your take on this issue? What type of business model you use? What type of product are you producing? Of course, my apologies for the delay. Well, let me wrap up quickly. Yes, as you say, we are an innovation and R&D company. We have 200 employees and 60% are working on R&D studies. We talk about wind power, but let me also talk about solar power. We are producing solar inverters. We are using this machine learning and AI in the production of solar inverter in terms of producing interrupters and maybe using this facility in a high capacity level. We need these machines functioning. So we have to also predict and prevent these possible damages, losses and failures of this machinery. For that reason, as Huawei, we rely on AI. In our inverters, we use, for example, if you know, there is a problem of arc problems. When there's a short circuit, it may lead to a burning of the machine. We have AFCI. There's an arc production. Thanks to this AI model, we can also diminish and eliminate these arcs within the system. Thanks to the support of the AI system, they can also learn about these patterns of the arcs. They can also eliminate, detect and eliminate directly. We are using these local algorithms. They detect these machinery and they can prevent the possible arcs without interrupting the working process of the machinery. On the other hand, yes, we talk about solar energy and wind energy, but in terms of battery, cooling plays a crucial role. For that reason, the algorithm that we use for AI, as you already know, for batteries, the temperature, room temperature is really important because of the high risk of fire. For that reason, they have to detect the environment, they have to see the temperature, desired temperature. Between the lines of batteries, there is a state of charge. They can diminish the temperature range to 3 Celsius grades. You can see in the field we can see some dust problems and they can degrade. They can do self-cleaning. We improved and developed self-cleaning technology. Due to time limits, I cannot talk all about the technologies, but Huawei and other companies are developing these type of technologies. So getting back to the essence of the topic, using these data and optimizing this data is important. In this sense, we have to analyze and monitor all of the data in terms of processing the data. Thanks to processing this data, we can have a better performance and we can have a maximum level of outcome. For that reason, we are benefiting AI. Thank you so much. Thanks. Maybe, of course, we'd like to have some questions from the audience as well, but let me first of all share my notes with you. Let's hear it all together. As Mr. Murat mentions, we lack standardization. The standards are far too weak as compared to the data we gather from the tribunes. In order to analyze and benchmark all of the data we gather from the tribunes, we need AI. Mr. Güven mentioned something, a comment, rather a negative comment. Climate change complicates the pattern recognition. As AI, we can recognize the patterns, but we are not sure if we will be seeing 30 degrees in December. Mr. Jem talked about visualization. Thanks to visualization, data can be processed and read by a large staff so that they can interpret the data well and more efficiently. It's also necessary to use AI in order to protect the machinery so that they can have a long life cycle. We have to evaluate and process the data from the producers. It's really a problem from part of the tribunes. The producer sends us data and we have to rely on that data. And anomalies about the data, maybe they do not lead to failure, but in a long term they may lead to failure. We have to analyze it. These are my notes and very valuable information. I have questions, but before I continue with my questions, I'd like to give the floor to the audience. Do you have any questions? I see that we don't. Well, my question is addressed to 3 people, except Mr. Güven. To whom? To whom these data belong? Well, as I said before, these data are produced by the turbine companies, but the owner of the plant, whoever is the owner, the data belongs to this person. I worked with the contracts. It's not openly discussed, but if they have their own IP on control system, if they do not have it, the wind energy and the electric energy belongs to the turbine owner. Well, to put it clearly, whoever analyzing the data is the owner of the data. After you own the data, in order to predict the failures, you have to process the data. Maybe for part of the solar systems, they have to have a managing system. Yet, after you gather this data, the most important part is what you do with the data. You have to analyze, you have to issue a report and take action. Whoever takes this action is the real owner of the data. I totally agree with Mr. Murat. Whoever owns the turbine is the owner of the data, but there's a complicated part here, as I have previously mentioned. There is a know-how and intellectual property in question. Provider of the turbine is not willing to share these data in terms of data security, storage security. Maybe they are reluctant in the sense. It's really comprehensible. We discussed this issue with the turbine owners. Maybe in the near future we will have more clear statements in the contracts. All of the data cannot be accessed through database. Maybe we can receive the majority of the data, but the turbine owner has access to all of the data. According to the supply contract and maintenance repair contracts, we will have more clarity in the future. It's an open question, but we will have the answers. I believe we will have a clearer answer to this question in the future. Maybe standardization will be the answer to all this question. Mr. Güven, yes, there are a lot of hybrid studies, maybe in terms of solar and wind energy hybrid usages, and there's some storage problems. So in this plant, solar system, wind systems are co-working, but there's an energy limit. Maybe we lose this energy. We have to reflect it in the feasibility reports. After 8,700 hours, is it 1 week, as you mentioned? I believe 1 year later, this hour. Can you just predict the direction and speed of the wind? When we talk about the weather, they are also asking predictions about 1 year later, in 10 years. It is about the modeling of the climate. Climate modeling is the key. So 1 year later, what will the speed of the wind will be is not predictable. But we are working with the climate modeling methods, and we can estimate approximately, we can predict, we can take the actionable steps. So this is one side of the issue. Weather forecast is one side of the issue. Short period forecast is possible, yet a forecast of 1 year and 3 years is the field of the climate modeling systems. But we can provide an insightful information and prediction so that you can use it in your model. If you do not have any further questions, we are closing this session. Thank you so much to all participants.